Welcome back to another exciting episode of our Bitcoin Tech Tales series. Today, we'll dive into the technical side and discuss an essential update to Bitcoin called Segregated Witness, or SegWit. We will also explore how Bitcoin's address format impacts transaction size. This matters because larger transaction sizes mean higher transaction fees. Moreover, transaction size can affect the number of transactions that fit into a block, given the block size limit. We understand that this episode might be more technical, but fear not. We'll break it down and simplify it as best as we can. And if it's still a bit overwhelming, you can skip to our next episode. So let's get started. On average, there is a new block every 10 minutes. Since there is a block size limit, there is also a limit to the number of transactions processed per time. Over time, the number of Bitcoin transactions has increased. Therefore, there was an increased debate on how to grow the number of transactions per block. The easiest solution would be to increase the block size limit, which would congest the Bitcoin network and cause other issues. Therefore, the Bitcoin developers introduced a new fit for the future Bitcoin software update called Segregated Witness or SegWit. Before we can explain the impact of SegWit on transactions and block sizes, we first need to look at distinct types of Bitcoin addresses. Before SegWit, all Bitcoin addresses began with number 1. We named them legacy addresses. SegWit introduced two new types of addresses, the addresses starting with the number 3, called SegWit addresses, and the addresses beginning with BC1Q, called native SegWit. Remember the Bitcoin address from Jane and Tom? They both have a native SegWit address. Developers recently introduced the new Bitcoin Taproot software update and a new address starting with BC1P. The type of Bitcoin address on certificates we use for payment decides how the wallet constructs the transaction. For payment with the certificates issued to the legacy address, the wallet uses a transaction form with only one box for transaction and witness data. You can find the place for the witness data in the middle of the box. We will name this kind of transaction a legacy transaction. However, the transactions for payment with the certificates issued to the SegWit and Taproot addresses have two boxes, transaction data and witness data. We will call this type of transaction a SegWit transaction. For accuracy, we must state that the size of the witness data is on average the same size or higher as transaction data, although we represent the witness box in our movie much smaller. Before SegWit, the block size limit was 1 megabyte, and the transaction size depended on the total data size of the transaction and witness data. With the launch of SegWit, the Bitcoin protocol separated transaction and witness data. Alongside this separation, a new method for measuring data size was implemented using weight units. Although weight units are still based on byte size, they allow transaction data to be given 4 times more weight than witness data. Before we continue, we must point out that mixed transactions are possible where legacy and SegWit certificates are used together for payment. Explaining it, however, is beyond the scope of this movie. Let's look at an example to see how the SegWit upgrade affects transaction costs by changing how transaction size is calculated. We calculate the weight unit of two transactions. The first is a legacy transaction, and the second is a SegWit transaction. Both transactions are the same size, with the transaction data being 350 bytes and the witness data being 450. Thus, the transaction size is 800 bytes. According to the Bitcoin protocol, the transaction and witness data are stored in one box in the legacy transaction. Due to this, the size of this transaction measured in weight units is 800 multiplied by 4, which equals 3,200. In the SegWit transaction, the transaction and witness data have a separate box. Therefore, we calculate the transaction size measured in weight units differently. We multiply the transaction data size, which is 350, by 4, and add the witness data size. The result equals 1,850. In our case, this is more than 40% smaller than the size of the legacy transaction. Instead of weight units, we can also use vbytes or virtual bytes. Virtual bytes are weight units divided by 4. In our example, this would mean 800 vbytes for the legacy transaction and 462.5 for the SegWit. Because you pay a fee based on the transaction size in weight units or virtual bytes, the payments with SegWit or Taproot addresses are much cheaper. At the time of the creation of this movie, using the native SegWit address was the most affordable choice. The new SegWit weighting mechanism allows more transactions in the block due to the change in the block size limit, which is now 4 megaweight units. In addition, transaction size is measured in weight units, with transaction data weighted 4 times and witness data weighted only once. Block size discussions in 2017 caused controversy in the Bitcoin community. Some early Bitcoin supporters disagreed with changes to the Bitcoin rules introduced by the SegWit update. They changed the Bitcoin protocol to allow a block size of 8 megabytes and began to build their blockchain branch on the 1st of August, 2017. They call this protocol and currency Bitcoin Cash. Just a friendly reminder: Bitcoin Cash is not Bitcoin. That concludes our technical exploration of SegWit and transaction size. In the upcoming episodes of the Bitcoin Tech Tales series, we'll explore the world of Bitcoin nodes. We'll look at miners' tasks to add new transactions to the blockchain. To simplify the process, we'll focus on one task at a time and fade the rest, making it easier to follow. Thanks for joining us, and we'll see you next time.